Mm-hmm. All right, so here, our first step with any probability, we're going to identify the situation as either independent or dependent. Remember, dependent changes, independent stays the same. So my denominator is going to change for dependent, stays the same for independent. Then we're going to write a fraction, or really a ratio, but we can say fraction for our purposes, for each event. We're going to do, and there might be 2 events, there might be 3, 4, or 5. A compound is more than one event happening. So if I just wanted to find the probability Maya walked in, it would just be 1/3, and I would just stop my day. Okay? And then we're going to multiply. And after multiplying fractions, what do we normally have to do? Our last step is start to simplify. Okay, and then we simplify if needed. Sometimes we might not need to simplify, which is fine. Okay, so there are 5 slices of pepperoni, 3 slices, so there's 5 slices of pepperoni, there's 3 slices of cheese, and 2 sausage. So how many total pieces do we have? 10. Okay. What is the probability Amy selecting a slice of pepperoni, eating it, and then doing getting cheese? So is this independent or dependent? Dependent, because the number of pieces is going to change. So for my first slice, what's the probability? So we want the probability of getting pepperoni and then a cheese. So I'm going to abbreviate myself. So then I can write pep and cheese. That's good enough. All right. Can anybody tell me what is my probability of me getting pepperoni if there's 5 pepperonis? Nick?
50%.
Yes, but as a fraction though.
1/2.
1/2, or we can do 5/10. That'll work too. You can simplify if you want to. It doesn't matter. All right. Now, since Amy ate a slice,
Wow.
how many pizzas are left for her to choose from?
9.
9. So that's, now how many cheeses do we have?
3.
3. So it would be 3 nights. So we're going to multiply 5 times 3 is 15. 10 times 9 is 90. We could have also simplified our fractions, and that simplifies to 1/6. So our probability is 1 out of 6. Not very likely, but it could happen. Okay. All right. Example 2, a spinner is split into 5 equal sections. 1 pink, 1 blue, 1 green, 1 yellow, and 1 purple. What's the probability of spinning 2 pinks in a row? What do we think, independent or dependent? Independent. Very good. All right, so I wanted the probability of getting pink and then pink again. So remember, independent, my denominators aren't going to change. They're going to stay the same. So there's 5 equal pieces. How many sections are pink? 1. So 1/5 times 1/5 would be? 1/25.
Ow. I thought it would be 2.
Multiplying fractions straight across.
I thought it was adding.
No, don't add them. That'd be 2/5. This could be your label, Keegan. Okay? Or you could write out a sentence if you want. I like to abbreviate if I can. All right. So here we have 4 marbles in a bag. The probability of drawing a red on the first try, and given that red is placed back in. So it's placed back in. Do we think it's going to change the total? No. So this is going to be independent. So I know my both scenarios, I'm going to stay with 4. So I want to find the probability of getting a red and then a green. So how many red marbles do we have? 1. How many greens do we have? So what's 1/4 times 1/4? 1/16. Right. All right. A bag contains 3 Snickers and 2 Hershey bars. So how many total do we have? 5. So we have 5 total. I'll keep that up there. What's the probability of picking 2 Hershey bars without being replaced. So this is going to be dependent. Very good. So I have 5 total bars, and then I know the next one, since it's dependent, that has to be 4. My denominators change for dependent. How many Hershey bars do I have to choose from for the first one? 2, right? Because we want probability of getting a Hershey's and another Hershey's. Okay? If I chose the Hershey on the first one, how many Hershey bars would be left for the second pull? Just 1. Very good, Ariana. So now we've got to multiply.
2
And what does that simplify to, Ethan? 1/10. So Mackenzie has 5 coins in her pocket, 2 quarters, 2 dimes, and a nickel. Mackenzie pulls 1 coin from her pocket, gives it to her mom. Then she pulls another coin from her pocket. So she's not putting the coins back. So this is going to be dependent. So she has 5 coins. We want to know the probability of getting a nickel and then a quarter. So there's a nickel, so that's 1. And since it's dependent, it has to be 4. And there's 2 quarters. So that's going to be 2 over 20 or 1/10. What's the probability of flipping 2 heads in a row? So the probability of getting heads first. So we want probability of heads and then heads again.
That's exactly what it is.
And then a half again. This is an independent event. So that would be 1/4.